this is the video lesson for section 6.2. Alright, so yesterday's lesson, which was 6.1, was based on the setting up of the periodic table. So Mendeleev came up with his, and he arranged it by atomic mass. And the modern periodic table, now we arrange it by atomic number. So today's lesson is more about the shape of the periodic table, not so much the order of the elements. Why is it not just a big rectangle? Why are these, columns shorter? Why is there this blank space here? Why does the first row only have 2 elements? So the first thing is, this is a picture of our periodic table broken up into more depth than the metals, nonmetals, and metalloids, because there's different types of metals and different types of nonmetals and so forth and so on. So you'll actually be coloring this periodic table in class. Okay, but let's just go over it a little bit. So group 1, not hydrogen, notice it's a different color. Group 1 are called the alkali metals. Group 2 are called the alkaline earth metals. Okay, so you have alkali and then alkaline earth. Groups 3 through 12, this whole lower middle rectangle, are called the transition metals because they transition us from one side of the periodic table to the other. All right, remember we colored that stair-step line before. Okay, here's the stair-step line. Okay, remember the elements that touch the stair-step line, except for, of course, aluminum, and then down here, these weird exception ones, just kind of disregard those. The ones that touch the stair-step are the metalloids, so the ones that are up under the stair-step are just referred to as other metals. Okay, they don't have a specific name. All right, we have the metalloids, which touch the stair-step, and then to the right of the stair-step are all the non-metals, but some of them have specific names. So this little triangular area right here has no specific name, so they're just called non-metals. Group 17, even though it is also non-metals, is specifically called the halogens. And then group 18, even though those are also non-metals too, are called the noble gases. And then of course across the bottom we have the lanthanides and the actinides. And you can tell the names of those because of the elements that are right before them, lanthanum and actinium. So those kind of give away those. Alright, so you need to be able to label a periodic table like this. But remember, we'll be coloring this in class. So let's move on to what the rest of this section is about. The section today is very, very short, so you'll quickly see why I chose to do this lesson as a video lesson. Alright, so the reason the periodic table is in this setup, where we have, different column heights, is it's all based on the electron configuration, which we learned that back in chapter 5. Hopefully you still understand that. So elements in the same group have similar properties. We've already discussed that many times at this point. But why do they have similar properties? Because they have similar electron configurations. So I need you to think back to chapter 5, or get your old chapter 5 periodic table out with the SPDF sublevels color. Remember, these first 2 columns are your S sublevels. So what I want you to notice is the electron configuration. This one ends in 1s1. This one ends in 2s1. This one ends in 3s1, 4s1, so forth and so on. So everything in the first column ends in s1. And you can do that with any column. Like remember, this is our P sublevel over here. Okay, so let's say I do right here. This ends in 2, 1, 2, 3, P3. This ends in 3, P3, 4, P3, 5, P3, so forth and so on. You can count over to any of them. Let's say I count over to here. 1, 2, 3, 4, 5, 6, 7. This ends in 3D7, 4D7, 5D7, so forth and so on. So everything in the same group has a similar ending in the electron configuration. All the ones in group 2 end in S2. All the ones here end in P1, then P2, then P3. The only thing that changes is which energy level we're on. These are 2p, 3p, 4p, so forth and so on. Okay, so that's what makes them react similarly and have similar properties. All right, so see, this is why I chose to do that section as video, because let's move on to section assessment. So into what 4 classes can elements be sorted based on their electron configuration? Well, back in chapter 5, how did we color the periodic table? We split into 4 categories based on electron configuration, and that was, of course, S, P, D, and F. Remember, we already colored that periodic table in chapter 5. We shaded in the first two columns as S. P was to the right of the periodic table. D was in the middle, those transition metals, and F were the lower ones at the bottom, the lanthanides and actinides. So number 2, why do the elements potassium and sodium have similar chemical properties? Well, real quick, find both of them on a periodic table. Sodium is Na, potassium is K. If you'll notice, they are both in group 1. So they are in the same group. And remember, y'all, a group is a column, not a row. So let me put column right here. Okay, a column is up and down. So if you notice, sodium is above potassium if you look at a periodic table. Since they're in the same group, they have a similar ending in the electron configuration. Since they're in group 1, they both end in what? S1. Alright, so number 3. Which of the following elements are transition metals? Well, transition metals are that lower rectangle in the middle, groups 3 through 12. So again, just get out a periodic table and let's look at them. Alright, Cu. If you look at a periodic table, Cu is in group 11. So is that in group 3 through 12? Yes, so that would be. Sr. If you look at a periodic table, Sr is in group 2. So that's not 3 through 11. Remember, transition metals are groups 3 through 12. This is in group 2. Alright, Cd. If you look at a periodic table, it is in group 12. So that is a transition metal. Au. If you look at a periodic table, it is in group 11. So that is a transition metal. Al. If you look at the periodic table, that is in group 13. So that is past the transition metals. So it is not a transition metal. Ge, if you look, it is in group 14. So that is also past the transition metals. And then last one, Co, is in group 9. So it would be considered a transition metal. So if I ask you a question like this, just remember groups 3 through 12 and then just look at the periodic table. Alright, next one. How many electrons are in the highest occupied energy level of a group 15 element? So y'all, this is where getting that periodic table out from chapter 5 might be helpful. Okay, so I'm going to draw a quick example of the periodic table right here. Alright, so remember, over here we have S, here we have D, here we have P. And this one is our other one for S. And remember, at the bottom, I don't know if you can actually see this on the video, but it doesn't matter, it's F. We won't get to that. Alright, so it said group 15. So we have group 13, 14, 15, 16, 17, 18. So we're looking at this group right here. Okay, it says how many are in the highest occupied energy level? Since it doesn't say sublevel, that means I need to include the S and the P. So let's just count over. So I would have S1 right here, and then S2, and then I have P1, P2, P3. So in other words, group 15 is going to end in S2, P3. So how many total valence electrons does it have? Well, 2 plus 3 is 5. Okay, so that's how many electrons are in the highest occupied energy level. Okay, we just start and count across. Or you could have just counted. 1, 2, 3, 4, 5. Either way works, okay? Kind of like you're counting valence electrons. We'll get to that in chapter 7. Alright, so let's erase this. Oh, never mind, just kidding. That was it. So again, hence the reason I chose this one for a video lesson, because it was super short. Alright, so that's 6.2. Like I said, we'll be coloring that periodic table like the first slide in class.